Top 10 Data Scientist Interview Questions and Answers. Data science is a rapidly growing field that combines statistics, programming, and domain expertise to extract insights from data. As the demand for data scientists continues to rise, so does the complexity of interview questions. Companies are looking for candidates who not only have technical skills but also the ability to think critically and solve real-world problems. In this article, we will explore the top 10 data scientist interview questions, providing detailed explanations and sample answers to help you prepare effectively. 1. What is the difference between supervised and unsupervised learning? Supervised learning involves training a model on labeled data, where the input and output are known. The goal is to learn a mapping from inputs to outputs, which can then be used to predict outcomes for new, unseen data. Common algorithms include linear regression, decision trees, and support vector machines. In contrast, unsupervised learning deals with unlabeled data, where the model tries to find hidden patterns or intrinsic structures within the data. Clustering and dimensionality reduction are typical unsupervised learning techniques. For example, K-means clustering groups similar data points together, while principal component analysis, PCA, reduces the number of features while preserving variance. Both approaches have their strengths. Supervised learning is ideal for prediction tasks, while unsupervised learning is useful for exploratory data analysis. Understanding the difference is crucial for selecting the right approach based on the problem at hand. 2. How do you handle missing data in a dataset? Missing data is a common issue in real-world datasets and can significantly impact the performance of a model. There are several strategies to handle missing data, including deletion, imputation, and using algorithms that support missing values. Deletion involves removing rows or columns with missing values, but this can lead to loss of valuable information. Imputation, on the other hand, replaces missing values with estimated ones, such as the mean, median, or mode for numerical data, or the most frequent category for categorical data. Advanced techniques like k-nearest neighbors, KNN, or regression imputation can also be used. Another approach is to use algorithms like XGBoost or Random Forest, which can handle missing values internally. The choice of method depends on the nature and extent of the missing data, as well as the specific requirements of the analysis. 3. Explain the bias-variance trade-off. The bias-variance trade-off is a fundamental concept in machine learning that describes the trade-off between a model's ability to generalize and its ability to fit the training data. Bias refers to errors due to overly simplistic assumptions in the learning algorithm, leading to underfitting. High bias models fail to capture the underlying patterns in the data. Variance, on the other hand, refers to errors due to the model's sensitivity to small fluctuations in the training set, leading to overfitting. High variance models capture noise as if it were a genuine signal. The goal is to find a balance where both bias and variance are minimized, resulting in a model that generalizes well to unseen data. Techniques like cross-validation, regularization, and ensemble methods can help achieve this balance. 4. What is cross-validation, and why is it important? Cross-validation is a technique used to assess the performance of a machine learning model by partitioning the data into multiple subsets. The most common method is k-fold cross-validation, where the data is divided into k subsets, and the model is trained on k1 subsets while being validated on the remaining subset. This process is repeated k times, with each subset used exactly once as the validation data. Cross-validation helps in obtaining a more reliable estimate of the model's performance by reducing the risk of overfitting. It also provides insights into how the model will generalize to an independent dataset. By using cross-validation, data scientists can fine-tune hyperparameters and select the best model, ensuring robustness and reliability in real-world applications. 5. What is the difference between L1 and L2 regularization? L1 and L2 regularization are techniques used to prevent overfitting in machine learning models by adding a penalty term to the loss function. L1 regularization, also known as lasso regression, adds the absolute value of the coefficients as the penalty term. This tends to produce sparse models, where some coefficients are exactly zero, effectively performing feature selection. L2 regularization, or ridge regression, adds the squared magnitude of the coefficients as the penalty term. This shrinks the coefficients but does not set them to zero, resulting in a model where all features are retained but with reduced impact. 6. How do you evaluate the performance of a classification model? Evaluating the performance of a classification model involves using metrics like accuracy, precision, recall, F1 score, and the ROCAUC curve. Accuracy measures the proportion of correctly classified instances, but it can be misleading in imbalanced datasets. Precision measures the proportion of true positives among the predicted positives, while recall measures the proportion of true positives among the actual positives. The F1 score is the harmonic mean of precision and recall, providing a balanced measure. The ROCAUC curve plots the true positive rate against the false positive rate at various thresholds, with the area under the curve, AUC, indicating the model's ability to distinguish between classes. Choosing the right metric depends on the specific problem and the cost of false positives versus false negatives. 7. What is the central limit theorem, and why is it important? The central limit theorem, CLT, states that the distribution of sample means approximates a normal distribution as the sample size increases, regardless of the population's distribution. This is a fundamental concept in statistics because it allows for the use of normal distribution-based methods even when the underlying population distribution is unknown. The CLT is crucial for hypothesis testing, confidence intervals, and many other statistical techniques. For example, it enables data scientists to make inferences about population parameters based on sample data. Understanding the CLT is essential for interpreting results and making data-driven decisions, as it provides the theoretical foundation for many statistical analyses. 8. What is the difference between correlation and causation? Correlation refers to a statistical relationship between two variables, where changes in one variable are associated with changes in another. However, correlation does not imply causation, which is a cause and effect relationship where one variable directly influences another. For example, ice cream sales and drowning incidents may be correlated because both increase in the summer, but one does not cause the other. Establishing causation requires controlled experiments or advanced statistical methods like causal inference. In data science, it's crucial to distinguish between correlation and causation to avoid misleading conclusions. Misinterpreting correlation as causation can lead to incorrect decisions and flawed strategies, emphasizing the importance of rigorous analysis. 9. What is a confusion matrix, and how do you interpret it? A confusion matrix is a table used to evaluate the performance of a classification model by comparing actual and predicted values. It consists of 4 components: true positives, TP, true negatives, TN, false positives, FP, and false negatives, FN. TP and TN represent correct predictions, while FP and FN represent errors. From the confusion matrix, metrics like accuracy, precision, recall, and F1 score can be derived. For example, precision is calculated as TP plus FP, while recall is TP plus FN. The confusion matrix provides a comprehensive view of the model's performance, highlighting areas where it excels or struggles. Interpreting the confusion matrix helps in fine-tuning the model and improving its predictive power. 10. How do you handle imbalanced datasets? Imbalanced datasets occur when the distribution of classes is not uniform, leading to biased models that perform poorly on the minority class. Techniques to handle imbalanced datasets include resampling, synthetic data generation, and algorithmic approaches. Resampling involves either oversampling the minority class or undersampling the majority class to balance the distribution. Synthetic data generation, such as SMOTE, synthetic minority oversampling technique, creates new instances of the minority class. Algorithmic approaches include using class weights or choosing models that are inherently robust to class imbalance, like decision trees or ensemble methods. The choice of technique depends on the specific problem and the desired trade-off between precision and recall. Preparing for a data scientist interview requires a deep understanding of both theoretical concepts and practical applications. The top 10 questions covered in this article provide a comprehensive overview of the key topics you may encounter. By mastering these questions and their explanations, you can confidently demonstrate your expertise and problem-solving skills during the interview. Remember, the goal is not just to answer correctly but to showcase your ability to think critically and apply your knowledge to real-world scenarios. Good luck!